And welcome back. Now this is part 2 of the LED cube, which we touched upon a few weeks back, and we got as far as having this cube like this, but with just some basic wiring checks, code running, just to prove that all the LEDs were wired up correctly. So I think it's about time we just finished off that bit of code to find out how we create patterns on here. Although this is of course a 2x2, so there's not an awful lot of patterns you can do with it really. And then we can move on to our 3x3x3, which is a little bit more impressive. One caveat I would say at this point here is looking at this LED cube via the camera screen now. It's very difficult to get a sense of perspective, and sometimes it's very difficult to know which LEDs are being lit up. Is it the front ones or is it the back ones? If I stick a pointer through like this, it might be slightly easier to gauge which ones are being lit up. But it is a little bit confusing compared to real life when it's blindingly obvious, because obviously you've got depth of field. What we need is stereo TV or 3D TV. If only they'd invent something like that, then we'd be alright. Anyway, let's move on then to find out how we actually put patterns onto this LED cube. And let's go over some quick fundamentals, which I left you with last time. That is, well, fundamental to the whole thing really. Time for a quick diagram, I think. So let's start with a diagram of the cube, which is like this, and we've said all the anodes are connected together as layer 1, so power is supplied into layer 1. Layer 2 identically, but power is only ever applied to layer 1 or layer 2, never both at the same time, because that would just overload our Arduino. Well, alright, maybe you'd get away with it with 2 layers, but let's face it, if you've got 3 layers or 4 layers or even 8 layers, there's no way the Arduino would cope. Unless you want to put loads and loads and loads of transistors in, which you don't need to do. What we do here, we only display the LEDs on one layer at a time. So for example, if you were going to display this LED here, let me use my pointer, this LED here and this LED here at the same time, quote unquotes, what you'd actually be doing is switching on layer 1, allowing current to flow down here, so this went on, then you switch layer 1 off and all the columns, then you switch layer 2 on, and then you switch this LED on. Then you switch layer 2 off, switch off all the columns, go back to layer 1, repeat. Now you might think, do what? You're switching it on, you're switching it off, you're coming down, you're switching it on, you're switching it off, you're coming back. Yes, that is exactly what you're doing. Because you're doing this thousands of times a second. Well, hundreds anyway. Well, maybe thousands, I don't know, I haven't measured it. I think an Arduino can handle a few thousand iterations a second. So because it's displaying that LED followed by that LED thousands of times a second, switching them on or off between layers, you, the viewer, sees them as being permanently on together, but they're not. Okay, so as long as we establish that, so that on one layer the LEDs are on or off, but they're never on or off at the same time as the next layer, or indeed the next layer down after that. So how can we represent this in code? Given that we're not on a Windows 10 machine here or a Mac, we've got limited memory, so we have to employ some techniques that are fairly common throughout the embedded microcontroller industry in squeezing things together. And in fact it makes programming, I was going to say easier, but that would be a lie frankly. It just makes it straightforward though, because you're dealing with known size of values. But let's not jump ahead. Right, so we're going to use this as our diagram, and we're going to use this as our little work sketch. Let me just move the camera to get everything in shot. There we are. Right. So what we're saying is, let's assume now that we're going to create one frame where this LED and this LED is on together, in quotes. They're not on together, of course, they're flipping backwards and forwards, but to us it looks like they're on together. How would we represent that? and that is what's known as a frame. So the state of all the LEDs at any one particular instance is what's known as a frame. And what we're saying is we want column 1 on layer 1 and column 1 on layer 2, for example. So this is our little table here. We have the columns across the top. We've only got 4, so it's easier to do. This is layer 1, the first row, and this is layer 2, the second row. So we're saying, yes, I want column 1 on layer 1, and I don't want 2, 3 or 4 on, so it's just that LED. And then at the same time, you know what I mean, the column 1 is also switched on for layer 2. So yes, I want that one on, but not that one, not that one, and not that one. And we said this flips backwards and forwards the layers thousands of times a second, but for how long? When do we move on to the next state? Well, that's determined by the duration for the entire frame. Now this is in milliseconds, so maybe when I put duration down here, we should put ms, milliseconds. And that's it. I mean, that is how you would create a state, a frame, for one particular instance of your cube. And this can then be written in computer language representing that state in binary. We're going to do layer 1 first, then layer 2. We can say, well, layer 1 is 1, that's the tick. Then we don't want any other 4 columns, so 0, 0, 0. Followed by layer 2, 1, 0, 0, 0. Those are our 2 layers representing column A, nothing, 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 column A, nothing, 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 and then finally the delay for all those, and we're saying we want that switched on for 1/4 of a second or 250 milliseconds. Brilliant, we've written our first frame. That was the good news. The bad news is you'll probably want several dozen, if not hundreds, even thousands of these frames to make a meaningful pattern on that cube. My rather pathetic attempts took several frames to just create that, but it's enough to get you started, and then you can while away the winter hours creating beautiful pictures. Okay, so this is how we're going to represent it. Now, this isn't 1,000, this is binary 1, 0, 0, 0, and this is binary 1, 0, 0, 0. This is, well, it should be an integer, but we're going to restrict ourselves to a single byte. And as you can know, you can only fit 255 in a byte, so that's 8 bits. So the maximum any one particular frame can be is 255 milliseconds. So what if you want it longer? We'll cover that a bit later on. For the time being, let's assume we're going to have 250 as our biggest frame length and 1000, 100. How are we going to represent in Arduino world? Easy, isn't it? We can basically say, just running out of room, we can basically say that we're going to define an array to hold the frames, all the frames that is. So what we're going to define is then, we can say char frame. Now the thing about frame is it's an array, so because it's an array we're going to put square brackets in it. We're not going to put a number in the brackets because it's indeterminate. We don't know yet. We're going to let the compiler figure out how many instances of this we've got in here. So in curly brackets like that, we're now going to put our array values. So first of all, it's for layer 1, and to create a binary value in a char is 1 byte. Okay, we're going to say 0b. So 0b means here comes a binary value. That's all that means. Here comes a binary value. We're going to say 1000, comma. Well, the next one's the same. So here comes a binary value 1000, followed by 250. That's it. That is how you define your first frame in Arduino. And if you were to run this in the sketch that I'm going to provide you, would have those 2 LEDs on together in quotes, for a quarter of a second, and that'd be it. Not a very exciting picture, I must admit, but it's the first of many. Okay, let's progress this a little bit and see where we might go next with our frames. Okay, just to give us a little bit more space, I've got the column diagram now up in the left-hand corner there, and we're going to repeat the exercise we did here, but for a different column, to get ourselves a better image than what we've got at the moment defined. So we're not going to draw out this table again. We are going to pretend we are and just do it this way. So what would our second frame be? If we're looking at the display here, so far we've got column 1 defined for both layer 1 and layer 2. Now let's just bring back the main one. So it's this one and this one. Let's assume what we're trying to do is then light up these two at the front here, then these two at the back here, and then these two at the back there, and then we just repeat round. So basically we get an anti-clockwise circle of LEDs, both LEDs lit up at the same time. Just for simplicity, let's follow that. Okay, right. So with that diagram in the top left hand corner there, we've already established our first frame, which is column 1 on both layers. The next one will be column 2 on both layers. So given our example here, we're saying for layer 1 we don't want the first column done, we do want the second one though, and then we don't want the third one, and we don't want the fourth one. And for layer 2 it's exactly the same. All right, so layer 2 in this whole example is going to be identical, just to make things easier. The next one after that, because we want one at the back now, so we want column 4 lit up before column 3. So we say 0, 0, 0, 1, 0, 0, 0, 1, and then finally we want the column 3 lit up on both. So 3 will be 0, 0, 1, 0, comma 0, 0, 1, 0. Now if you're thinking, I missed that, what are you talking about? Let's just whiz through that in a tiny bit more detail. Originally we set up the frame for this column here, column 1, for both layers. This is 1, and the rest of the columns, column 2, column 3, column 4, are off. That's what this represents. Column 1 is on, 2, 3, 4 are all off. When we move on to the next frame, we want to say, I want column 2 on now, but not column 1, not column 3, and not column 4. So column 2 is obviously in the second position, so column 1 is off, column 2 is on, 3 and 4 are both off. I won't keep talking about layer 2 because it merely replicates what's on layer 1. Okay, so we'll concentrate on layer 1. Now, once we've lit up this column here on both layers for a quarter of a second, we then want to go to this back one here, which is column 4 and not 3. Okay, so it's this one here, column 1 note, column 2 note, column 3 note, yes, column 4, we do want that on. And then finally we want this final column at the back here, column 3 on. So 1 note, 2 note, 3 yes, 4 no. These make up the rest of our frames, and we're going to have these on for the same amount of time, because believe me, you're going to have enough to do just getting the frame to look anything without fiddling about with these values too much. Okay, so these now represent our additional frames to put into here. So our final code, if you like, simply to make a rotating LED like that on all the 4 columns, 1, 2, 4, 3, like that. This is it. It's this one up here plus these 3 here. So what we can say is, I've got to keep looking down to find out where my page is. So char frame, we don't know how many are going to be in there. You compiler, work it out for us, please. Open squiggle brackets. That's not a very good squiggle bracket, is it? There we are, curly braces. So we'll repeat this. Now remember, it's always got to be 0B first, because if you don't put 0B, the compiler assumes you're going to be inputting, well, it'll work out from this that that's an integer value, which is most definitely not what you want. And in fact, it would complain. Well, my compiler would complain anyway. It says, hang on, you're trying to put 1,000 into a single character. That doesn't fit. And it would give me a warning on compile. So we're saying 0B, binary value about to arrive. So for we won't repeat this, but we'll do these now. So 0, 1, 0, 0, 0, 1, 0, 0. Whoop, forgot the 0B, see how easy it is to do. 250, comma, and then repeat this for the next line. So 0B, binary value on its way, 0, 0, 0, 1, comma, blah, and then this final one here, 0B, binary value on the way, and it's this final value here, not column 1, not column 2, yes column 3 at the back, not column 4, and repeat 250. And then finally we close our squiggle brackets, and the compiler can then add up all these bytes and go, oh yes, that's 26 or whatever it is I'm going to put in here for you. Brilliant. So what we've defined now by doing all this is a single anti-clockwise rotation of both layers of the LED, and it will just keep doing that forever and ever. Should we plug that into some code and see if it works? Okay, let me get up the code window first. Right, so all I've done in this code example here, apart from define the pins and the columns, which we'd already done last time, so there's no change there, is to define now here our frames. Remember, each line here represents a frame running for a certain length of time, and I've transcribed here what we just did on that notepad. So always layer 1 first, followed by layer 2, followed by a time. Well, before we explore the actual code underneath, has it worked? Let's have a look. Well, blow me down. There it is, look. Whizzing round, well, whizzing, we said 250 milliseconds. That's a quarter of a second on each. How do we know that's really working? Well, just as an example, if we take that down to, say, 50 milliseconds on all those. Oh, actually I made a mistake. I put 255 in the last one. 5 more milliseconds. Anyway, we'll leave it at 55. So we're going to speed that up. Let's have a look what happens when I upload this one. Off it goes. Trundle, trundle. Uploading the code. Launching. Yes, thank you. And whoa, that's so fast you can't even follow it anymore. Let me see. Yeah, in real life, because the LEDs are much redder and brighter, it's still extremely fast. I mean, that is too fast to follow. In a real pattern, you'd probably only use 50 milliseconds if you've got a lot of columns or something. So we'll put that to 150. Oh. It's extremely difficult to type at the moment because the camera's so close to my workbench here. Right, 155. Let's see what difference that makes. Quite a bit, I think, because it's 3 times as long, isn't it? Off we go. Launching, compiling. All right, there we are. That's a little bit quicker than what it was the first time, but not as quick as it was just a second ago. So there we are then. That's pretty much how we define a frame, and from that you might already be ahead of me here, probably are, and thought, well, if I can do that for these frames, then we could change the second frame to do something else. For example, if we just wanted this rotating LED to happen on frame 2, that is the lower frame, and not frame 1, all we'd have to do is put a 0 in here. Well, let's do that, why not? You see, if you download this code, you'll be able to experiment like this with this particular sketch, and when you've done it, it'll be so blindingly obvious what it's doing. So what we're saying is we don't want layer 1 to turn on at all now, so, well, it won't. Simple as that. It will still get its little time slice. There we are, look. Now actually you can see I've made a mistake, not in my code, but when I grabbed this out of the cupboard today to wire all this up again, I'd actually taken away the Arduino, so I had to connect it up again, and as you can see, the layer that it's now rotating on is the top layer, and that is not layer 2, that is layer 1. So I've got my layer 1 and layer 2 cables transposed. So if we just zoom back out here and just take that picture off screen as well, you can see that the layer pins, which are these two here, which are driven by the transistors, actually are here on pins, was it 3 and 4? Yes, and they're the wrong way around. So I'm going to have to switch those round the other way. There we are. Now it's lighting up on the bottom layer. That's the way to do it. Fine, so the top layer is not being lit at all, and that's exactly what our code tells it. Okay. Now already you're probably thinking, I've got it, stop talking, I just want to get on with it. Well, fine, that's fine, you can download the code and you can play with it. Let's just have a look at the rest of the code now. Right, so this is the setup. This is just setting inputs and outputs for the various columns and layers. We'd covered all that in the last video, so I'm not going to go through that now. This is the main loop. This is the bit that's different. Instead of hard coding the columns and just outputting a value from a loop, here we're now reading the frames. Now the first thing we're doing is declaring our start time, because if we're saying on here, for example, we want this to run for 250 milliseconds per column, so it comes onto this LED, keeps displaying that LED for 250 milliseconds, but without stopping, it has to keep flicking backwards and forwards between the layers. How do we know when we've reached our 250 milliseconds? And the answer is we take a snapshot of the time at the start of the loop and go, right, so I'm here, I'll know what time it is, and this is the static. So when we update it, it will remain updated, it won't be overwritten. Then we go and get our current frame number. So which frame are we on? If we just look back at this bit of code here. So on here, for example, this was our very first frame that we'd ever designed. How do we know we're on this frame and not on the 20th frame further down? Because we need to then know how to get to the next frame. Well, that's where this little counter comes in. This counts which frame we're currently on, or points to, let's say. It doesn't count, it points to the current frame. So now we're saying do level 1 and do level 2. Now, okay, I've sort of cheated here a little bit because you wouldn't normally do it like this, but for demo purposes it's acceptable. It makes it clearer that we're doing level 1, then we're doing level 2, and more to the point, they are independent to some degree. Yes, normally there'd been a loop and we'd say do level 1, then level 2, then level 3, and then level 4 or whatever. But here we can say we're doing level 0, then level 1, which is level 1, level 2 in our terms. The frame we're passing in is the current frame, the one we've just read out of our array. The one at the top here, so it's just one of these lines, just one of those. Yeah. So level 1 gets that, level 2 gets that, and the time is a constant for them both to share. And then we're saying, have we displayed, having gone round this loop umpteen times, have we actually displayed that single frame for long enough? So we say, go and get the frame duration we should have displayed it for, so in this case 250 milliseconds. Is that equal to the current time, the milliseconds? Forget this bit about the delay multiplier. It's an easy way of getting a longer delay when you're testing things out. But just skip that for a minute. We're saying, is the current milliseconds now greater than your current frame duration plus this frame start time? So the frame start time was up here. We should have had 250 milliseconds added onto that. Well, is the current time greater than that now? If not, forget it, just carry on displaying it. So we're just displaying that very first frame, which in our terms, of course, is just this very first column down here. So it's still displaying that one LED. What to you and me is a very quick flash, to a computer is an eternity, and it just keeps displaying that LED. But eventually, of course, the time will run out. And then we can say, right, oh, we have exceeded it. So now the milliseconds is now at 251 or something. It's going to be pretty accurate, actually. Great. We need to move on to the next frame. Well, in our array, we have to move on 3 bytes. Because when you think about what our frames consist of, that's the one frame, 0, 1, 2. So this must be 3. So the start of the next frame is at frame 3. And that's 4, That's 5, and the next frame will be 6. Okay, so that's why we always add 3. Now there's probably different ways of doing this, and I'm sure the guys that create those beautiful 8x8x8 frames, they got techniques that I've never even heard of. But I'm not into cube building really, so I guess if you can do it this way and make some decent stuff, then you'll probably also experiment and investigate how there's other guys do it. So let's just carry on with this rather simple code. We say, right, we're moving on the frame to the next frame, which is plus 3 bytes. Have we run off the end of the frame? Is there actually more frames available to us? Because if not, we'll start reading program code and goodness knows what. So if it's greater than the same frame size, we're going back to the beginning, frame 0. Otherwise, we just keep the current value of frame, reset the start time here back to the new value of millis, so we can count 250 milliseconds or whatever the value is for the next one, and carry on. Now you might say, okay, what does this do layer do then? How does the value get printed out, if you like, or displayed on that LED? Right, well, let's have a look at that. So for each layer it's the same, no different. We're saying which layer number are we? Now this is 0 based, but never mind about that. There's the frame. The first thing we do is say whatever layer number we're on, set the output high. If we go back to our very first picture, which is this one here, remember that each frame has a layer, and first of all we're setting this layer here, so this common anode for all of the LEDs is now high. So it's saying I'm allowing current to flow if one of these LEDs can be grounded somewhere. Okay, that's how we're doing that. So we're saying set it high. Now this here is what we need to understand and requires a little bit of explanation. So I'm going to have a little cup of tea, come back and take a deep breath, and we'll do that. Right, cup of tea duly made. Oh, you've got one too. Excellent. Well, let's enjoy it together, shall we? Right, so to understand this little bit, it's not difficult at all. It's just a little bit of binary maths, really, I suppose. Binary or bit manipulation, simple. Let's just have a quick recap how we're going to do this. Right, what it's saying here is, look, in this very first line, it's saying, how do I know whether to turn on the first column or not, column 1? Because it basically does this for 4 columns. Column 1, column 2, column 3, column 4. Simple as that, for the particular layer it's on. So it says for column 1, this one here, how do I know whether that first value, the first bit, has been set? So let's just have a quick recap on some binary maths. Really simple. Don't get put off by this because it's just not difficult. Remember when we created our array, what we said was our array looks like, okay, here comes a binary value, 0b, and then we said 1, 0, 0, 0. Okay, that was the first frame. So that meant column A here. That's column A, and then B, or column 1, I should say, column 1, 2, 3, 4. Okay. Now, if this is a binary value, which it is, and that's representing binary, what does that mean? Let me reposition the camera, we'll go through it. Right, so here we have our binary value. And if you remember that binary, for, well, any binary, but we're only having 4 bits here. So we start off with binary as 1 in the rightmost bit, then 2, then 4, then 8. And if we were moving on, it just doubles every time. It represents the value in that column. Well, we're not interested in 32 and 16, not for this little demo. You might do if you had an 8 column or 8 by 8 by 8. Anyway, let's not worry about that. So we're saying 1, 0, 0, 0 is representing this individual digit. Okay. Now, if we were to add up what this means in binary terms, we can say, well, that 1 in that position represents an 8, nothing for the 4, nothing for the 2, nothing for the 1. So that represents 8, and indeed that is exactly how you write 8 in binary. just as an aside, if you wanted to write 10, you'd write 8, 0, 1, 0, and that would equal 10. Okay, but we're not doing that here. We've only got 1, 0, 0, 0. Okay, that's our very first frame. But what about the frame that we've got on our next bit, which says 0, 1, 0, 0? How does that represent itself in binary? Well, let's just write it down here and find out. We can say 0, 1, 0, 0. So have we got any 8s? No, we haven't. Have we got any 4s? Yes, we have. So that's 4 plus, oh, no 2s, no 1s. So that's 4, isn't it? So if you like, 8 is representing column 1 and 4 is representing column 2. So let's go back to the code window and see how we use that to our advantage. We're saying if the current frame and 8, this is binary 8 now, equals 8, set that column low. And this is column, well, we've called it 0 because everything's 0 based in computer world, but it's actually column 1, isn't it? Column 1 is 2, 2 is 3, and 3 is 4, right? 0 based. What does this and 8 mean though? What does it mean? Current frame and 8 equals 8. Current frame and 4 equal 4. What rubbish is all this? Let's go back to our little book and have a look. For binary code, what we're saying is, I'm going to take myself off now so I can show you properly. Right, so we have our value. So this is this, which is that. Okay, that's 8. That's 1 representing. Now, with our code, if you look there, says current frame and 8 equals 8. Now, and in binary terms means put 8 underneath it. So what's 8 in binary? Well, funnily enough, it's the value we got there. And then we say and the only and means this value and this value. Yes, it's true, therefore it equals 1. This and this, well, we haven't got 1s in any of these columns, so they can never ever be true. All right, so that value is 8. What would happen instead of an 8, we had like this example over here of 10. Yeah, so we had a 1, 0, 1, 0 and 8, 1, 0, 0, 0. Would this work? Well, let's have a look. 1 and 1 is 1, correct. 0 and 0, well, it's got to be 0. 1 and 0 is 0, because they're not both 1s, are they? 1 and 0 cannot equal 1. And 0 and 0 equals 0. Well, that also equals 8. So basically, what we're saying is, as long as this first bit here is set, yes, we have got an 8. And, well, that's what we want in our code, isn't it? We want to know whether that first bit is set or not. So, we're saying, basically, is the first bit set? Does it represent 8? Yes, it does. Set the column low. For the next column, is the bit that represents 4 set? Yes or no? Well, in our example, no, it's not, so we don't do anything. Ditto for the 2, ditto for the 1. So this and, binary anding, basically just refers to this sort of addition. Both things must be set for the and to work, and because we as programmers are supplying a fixed value here, 8, 4, 2, 1, we know damn well that unless the incoming value represents the same bit value, it's never going to be true. And that is how you do binary addition. So you can have a look at that again, re-watch that bit of the video if you can, or Google it or something to get a better handle on it. But that's basically how we do it. Just to make things perhaps slightly a little bit clearer, we could have coded this a little bit differently as well. So what we could have said here, for example, instead of 8, we could have said 0b1000 equals 8, or indeed, forget the 8 there, we could have said 0b1000, because they both represent 8. 8 to us is 8, fine, but in binary terms it's 1000. Right, so that is equivalent. I could have put 8 there. If the current frame and the bit that represents 8 equals binary 1000, all the same, Okay, but to make it just easier to read, because binary is not the easiest thing to read, we can just put the decimal value in there, and we understand what's going on then. So that's a little hint for you, perhaps. Okay. Right, so what we're saying then is column 1 set is column 2 set is column 3, column 4. Right, so after we've done that, then we say, right, so we've turned it on for the, whatever, a thousandth of a second or something. Now we've got to turn the entire layer off again, and then turn all the columns off again. We have to turn the columns off as well, because otherwise when we turn the next layer on, whatever columns we had previously on would suddenly spring into life. You don't want that at all. That would certainly upset your little pattern. So we turn off the layer, turn off the columns. This all takes time, of course, but we're talking microseconds for that, microseconds. And then we come out of this do layer and move on to our next one, which is, funnily enough, layer 1, and do exactly the same, no difference at all. We treat each one of these layers independently. The fact they happen to look to us as though they're joined in some way, well, that's the magic of LED cubes, isn't it, I suppose? Right, so we do the layers, then we've talked about all this, about have I done it long enough, or do I just keep going on that until we run out of time, which of course sooner or later we will do. We'll then move on to the next frame, which, remember, is a frame is a complete set of data like this for layer 1, layer 2, and the frame duration. Okay. I'll let you play about with these durations, and you'll soon figure out the minimum that you can possibly use and the maximum. And one final thing here, look, if you notice this bit here, I'm printing out the free RAM and the size of the array, because at the moment with this code, the array has got to fit into your free RAM. How much RAM have we got? Well, if we compile this, you'll see that in the serial monitor window. In fact, we should have a serial monitor window waiting for us. So we have free RAM 1768, that's quite a bit really, because we've got 2K. Size of frame array 12. So we've got 12 bytes in here, 1, 2, 3 and 12. Good lord, it actually works out. So there's 12 bytes in the array, and we've got 1768 bytes of RAM in which to, well, one, contain this, but secondly to run our program in. Remember that Arduino will use some of that as part of its runtime memory. If only there was a way to store this frame information elsewhere and not use up all our free RAM. We'll cover that in a future video. Okay, that's it. That's how you create very simple patterns. I'll upload another sketch that has far more than this. And the technique that I mentioned where you might want to call this something, rotating LED anti-clockwise, layer 1 for example, and how you'd use that in the frame. But it's just a technique to make debugging a lot easier really. It doesn't use up any more memory at all. Okay, we just define what it is we want to use. Right, that's it. I think we've exhausted this particular 2x2x2. The next step will be the 3x3x3, but that'll just be a part video, because if you can do this for 2 LED arrays, the 3x3x3 just means these become a little bit more complicated, because you've got to address 3 rows of 3, and of course it's not just 2 here. We're going to have another column in the middle. Remember, there's 9 individual elements we need to address for every layer. Okay, not just 2. So it does bound up. Can you imagine doing an 8x8x8? I dread to think what the array must look like. Perhaps it's some special technique, but I can't imagine what it is. You've got to specify it somewhere. That's why we're doing a 2x2x2, just to get the fundamentals right. And if you build this and get this running, then you will most definitely be able to do a 3x3x3. Yes, it's more work, but the work is only in defining the frame itself and the patterns and getting that all right. But when you go beyond the 3, 4x4x4 or beyond that, it's a lot of work to do the patterns. Beautiful, yes. I've seen in an 8x8x8, I've seen sort of dolphins leaping through and whales, and it's just amazing. But by God, the work. Anyway, we're just doing the fundamentals here. Remember, these videos are all about how and why to jumpstart your project And who knows, somebody watching this video may start with this and end up with some 20 by 20 by 20 array on a Arduino Mega or something, and it'll be fantastic. Okay, right, not me though, okay, just don't get your hopes up, I'm not doing that. Okay, that's it for today. Thank you very much for watching. Don't forget to give me a thumbs up, and any questions, put them down at the bottom of this video. Where are you? There you are. Down at the bottom of the video, put some questions if you want pertaining to this video. And thank you so much for watching, and see you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below, subscribe, share, and give me a thumbs up. Thanks for watching. See you in the next video.